In this video, we're going to do some angle proofs. So we did some segment proofs in the last video, and let's go ahead and do our reference page for our angle proofs. We have all of our properties of equality still. We have our properties of congruence, just like in the last ones. We have some definitions that we need to remember. Definition of congruence, just like in the last one. Definition of an angle bisector. An angle bisector divides an angle into two equal parts. Also, definition of complementary and supplementary. And notice the line or the arrows that go in both ways, which means it's a biconditional. All definitions are biconditionals, which means if it's complementary, then the sum is 90. If the sum is 90, then it's complementary. It works forwards, it works backwards. Again, you see supplementary means sum is 180. Definition of perpendicular. Perpendicular lines form right angles. And the definition of a right angle equals 90 degrees, the measure of a right angle. The angle addition postulate works the exact same thing as the segment addition postulate. This angle plus this angle is equal to the whole angle. The measures are. Vertical angles theorem. If they're vertical, they're congruent. Complement theorem. If two angles form a right angle, then they are complementary. So right angle implies complementary. Supplement theorem. A linear pair implies supplementary. Congruent complements theorem. If A is complementary to B and C is complementary to B, then A and C have to be the same, and the congruent supplement theorem works the exact same way. Now let's do some practice for each of these. Justify each of the following statements using a definition, a theorem, or a postulate from above. If angle A is a right angle, then the measure of angle A is 90 degrees. And that comes nearly straight from right here. Right angle equals 90 degrees. That's the definition of a right angle. Number 2 says if angle X is supplementary to angle Y and angle X is supplementary to angle Z, then angle Y and Z have to be congruent. And again, that follows nearly identically. If A is supplementary to B, C is also supplementary to B, then the two angles have to be the same. A and C would have to be the same. That is the congruent supplements theorem. Number 3, notice you have these vertical angles here. Angle 1 and 2 are vertical, then the two angles must be congruent, which follows directly from this vertical angles theorem. If two angles are vertical, then they have to be congruent. So that's going to be your vertical angles theorem. And notice anytime instead of writing the word angle, I just use the angle symbol. If measure of angle P plus measure of angle Q is 90, then that means that they are complementary. And you've got to be careful with this one. Right here it is. If the sum is 90, that means it's complementary. If it's complementary, it means the sum is 90. Again, that's a biconditional statement. That is not the complement theorem. Complement theorem says if it's a right angle, if two angles form a right angle, then they are complementary. Okay, so you got to be careful with that because this did not say that this is a right angle. It does say that it's 90 degrees and that it is, but it does not say right here. We know that is a right angle, but it doesn't come out and say that's a right angle, so we got to be careful. And that would be the definition of complementary angles. If M and N form a right angle, now we have it. Right angle, then it implies that it's complementary. Does right angle imply complementary? And that's what we see here. Right angle implies complementary. That would be the complement theorem. Okay, number 6 says given the drawing, if L is perpendicular to M, then the angle 1 is a right angle. So perpendicular implies right angle. And that would be right here. Perpendicular lines implies right angles. That is the definition of the word perpendicular. And notice I'm using all sorts of abbreviations now, and that's perfectly fine. Definition, I'm just putting DEFN for definition, and then I just use the symbol for perpendicular there. That is not a number 1. There we go. Definition of perpendicular. Number 7, if W and X are supplementary, then that means that they add up to 180. So supplementary implies 180, and that can be found right here. Supplementary implies 180, and that is a biconditional, works both ways. That is the definition of supplementary angles. So number 7, definition of supplementary angles. Number 8 says if angle L is complementary to M, and N is complementary to M also, that they must be the same. So they're complementary to the same angle. If two angles are complementary to the same angles, then they are congruent. That can be found right here. If A is complementary to B, C is also complementary to B. If they're complementary to the same angles, then they're congruent. That is the congruent complements theorem. So number 8 is the congruent complements theorem. Okay, number 9. says A and B form a linear pair, then they are supplementary. So linear pair implies supplementary. Let's see if we can find that. And that's right here. Linear pair implies supplementary, and that is called the supplement theorem. A lot of times I'll see that called the linear pair postulate, and I'll actually probably use that more than the supplement theorem. That's what I've always called it. So let's go ahead and call that the linear pair postulate. Again, it's just another name for the supplement theorem. So again, number 9, linear pair implies supplementary is your linear pair postulate. And on any of these, if you can't think of the names, you could actually write out what it says. If two angles form a linear pair, then they are supplementary. You could have wrote that in the blank as a reason. You don't have to actually write the name of it. Number 10, N and P are complementary. That means that N plus P is 90. You can go back to your list. And it's found right here. Complementary implies 90. Again, it's a biconditional, so complementary does imply 90. So that would be definition of complementary angles. And again, that was number 10. Number 11 says, given the following drawing, JKM, which is this angle, plus MKL, which is this angle, adds up to give you the whole angle. That would be your angle addition postulate. This angle plus this angle equals the whole one, works the same as the segment addition postulate. And finally, number 12, if measure of angle R equals the measure of angle S, then they must be congruent. Now, if you remember correctly, a lot of times in that last section, we did these. If the measurement from AB is the same as CD, then that implies that AB has to be congruent to CD. We use that a ton, that definition a lot, and that is simply the definition of congruent. And again, if you would like to start just using the symbol for congruent instead of actually writing out the word, number 12 is the definition of congruent.